Welcome to Unit 1 of Pre-Calculus, where we will be talking about series and sequences. Before we jump into material, I want to give you an overview of what you will be working on in this first unit with some essential questions we will cover and that you should be able to answer by the end of the unit. So, essential question 1, what mathematical patterns exist in real life? How can I add large amounts of numbers together when they are all different? And what basic essentials about functions do I remember from Algebra 2? So those are just some basic topics that we're going to be covering over the course of this unit, and some essential questions that we'll come back to towards the end. And with that, we're going to jump into our first lesson. Please make sure that you have your notebooks out in front of you to take notes, along with a writing utensil. In this video, I'm going to cover function notation along with how to evaluate functions in many forms. First, we're going to start with a definition or two, and you can decide at the end which feels more fitting to you. So first, our formal definition is that a function is a rule. So this could be an equation, a set of ordered pairs, a situation, that assigns one element. So these elements, they could be numbers, they could be variables, they could be time if it's a real life situation. So it assigns one unique element in the domain, so with my x values, to a unique element in the range, so my y values. A more informal definition would be that a function is when each input of your function has only one output. So your x value has exactly one y value, not more than one. You can choose to identify whichever definition makes more sense to you, or figure out some combination of the two to formally define functions for yourself. And just a little example of a function. If I have an input, let's say 4, and I put it into my function, when I go to look for my outputs for this function, I should get exactly one number. So my input is 4, my output is 2. I should not get a second output, like 3. So if I had 3, then I wouldn't have a function. But if I just have my output of 2, then I have a function. Okay. So a function can't have more than one output. However, an output may have more than one input. So let's look at this example up here. If I have the function y equals x squared, what values can I input to x to get 9 out as my answer? If you answered 3 and -3, you're correct. If you forgot about the -3, that's okay, but it's just something to note that two different inputs can have the same output. That's okay. So I can have the ordered pair 3, 9 and -3, 9, and it would still be a function. Next, I want you to take a look at these sets, the set of ordered pairs, and identify if the set is or is not a function based on the outputs and inputs. Think about looking at the first question. Do any of the inputs have more than one output? Okay, we're going to go over that first question together. Looking at this first set of coordinates, or my first set of ordered pairs, I've got a set of inputs, so all of my x values. And I have a set of outputs, so all of my y values. Output, 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 output. So if I started, one way to just think of this in a kind of slowed down perspective, if I started by listing my inputs, well, I have 0, 1, -1, and 2 in 2 different points. If I listed my outputs, for 0, my output is 1. For 1, my output is 5, then 3. And then for 2, I have both 4 and -1. So this is one of those scenarios where I'm inputting 2 into my function and I'm getting out 2 values. So this will not be a function because 2 has 2 different outputs. Now I want you to stop and think, answering the second question. Do I have any values that have a repeated or different output? I want to explain the second question, particularly the 0, 0 coordinates. So if I were to list out my inputs and outputs, I've got 0 as an input, and then I have 0 as an output 2 times. But because these are the same number, I could really just list it once, and it would still be considered a function. So just because a coordinate happens more than one time doesn't discount this as a function. So this is a function, or this set of points is a function. Okay, and with that, we're going to move on. So far we've talked about how to identify functions based on given inputs and outputs. But one easy way or easier way to determine whether a set of values is a function is to graph it. And this is for those visual learners out there who really appreciate looking at graphs or figures. So if you have a graphed function, you can always do the vertical line test to figure out whether or not your graph is a function. And the way that this works is when you draw vertical lines throughout the whole graph, and a vertical line will hit the function only once. So each vertical line only hits the graph one time. That means that it's a function. So let's look at some examples. Hold on. Okay, there we go. And I would recommend just copying these 3 visuals down as a key so that you can recognize which are and which are not a function. So if I'm drawing vertical lines, these lines are going to go up and down through the function, and I'm going to draw a whole bunch of them on all sides. And if I look at these vertical lines, when I look at where they touch the graph, they only intersect the graph at one point. So this graph would be considered a function. Yes, it's a function, because each of these vertical lines only cross my graph exactly one time. If I do this for my next graph, well, at a certain point, and you can kind of see it, my vertical lines start to hit my graph at more than one point. In fact, there are 3 intersection points on that one vertical line alone. So in this case, because of all these intersections on my vertical lines, this is not a function. And this is, again, just a way to determine whether or not you have points or your values are a function graphically or visually. Lastly, if you look at this parabola, go ahead and copy it down. Would this be considered a function based on the vertical line test? Why? Okay, and we're going to keep moving along. So there are some other visual representations that you might find with functions, such as these 2 images that you're seeing in the video. So in this set of images, you'll get, for example, in this one, a set of inputs and a set of outputs with arrows connecting my inputs and outputs, acknowledging that they are connected. So looking at this first image, we want to follow the set of arrows across, so looking from 2 to -5, 5 to -5, and make sure that each input has only one output. So is this a function, this set of numbers, or is it not a function? Why? Okay, if you answered that this is a function, you are correct, because if you look at each of my inputs, so 2 only has one output, 5 only has one, 7 only has one, 9 only has one, 11 only has one, -3 only has one. The only thing that might have tripped you up is the 0 and the 5 as outputs. Both have two different inputs going into them, but remember that an output can have more than one input. My input just has to have exactly one output. Looking at the second image, comparing the two, is this a function? Justify your answer in writing. Why or why not is this a function? Do any of the inputs have more than one output? And for this is actually not a function, and the reason is because of this input 7. As you can see, I've got two lines branching out from it, or two arrows branching out from it, going to two different inputs. And so in this case, it would not be a function because 7 has more than one output. But the rest of them are actually okay. If it weren't for this 7, this would be considered a function. Okay, so when we talk about functions, or when we write about functions, we always want to use function notation to describe them mathematically. This will typically look like y equals f of x. And this is how you say this. I'd recommend just writing it down because it's not y equals f times x, which is what we're kind of accustomed to from our previous math classes. So in this case, y is your input and x is your y is your output, and x is your input into your function. Just as a note, your function can equal y, or it can equal f of x. They mean the same exact thing. So in this example down here, I've got y equals x squared plus 2x plus 3, and I have f of x equals x squared plus 2x plus 3. These two equations both mean the same exact thing. They're telling you the same exact thing about this function. It's just that one starts with y, one starts with f of x. Those two things are interchangeable, so you can switch them up whenever you feel like it. Okay, so from here, just to look at a little bit more function notation. So in this function, f of x is equal to the square root of x squared plus 1. F is the name of my function, x is my input, and then this whole piece over here is my output. So it's the pattern or the rule with what to do to x in order to get y. So you're squaring x and you're adding 1, or you're squaring your input and adding 1, and then you're taking the square root of that, and that is your output. So I want you to consider how to evaluate. So you've done this many times in previous math classes. If I ask you to evaluate a function, I want you to replace or substitute your variable or your input with a given number or expression. So in this case, I want you to evaluate f of 4. So with the same f of x function up here, I want to know what happens when you plug in 4 for x. Go ahead and substitute in. If you didn't get this one correct, that's okay. Just remember to use your order of operations when you're evaluating functions. That's something that seems like a very basic skill and a very basic idea, but it's actually something that trips a lot of students up just because it's not something that you may think you need to think about anymore. So as you go through assessments in this class and as you work on problem sets, just remember to follow your order of operations. Thinking about how to evaluate a function graphically, we're going to look at what we call a piecewise function. So this may look very new to you, and that's okay. It's just a different type of graph. So this piecewise function is just made from multiple pieces of different equations. So you may notice that on this left-hand side, it looks more like a parabola. And then when x equals 1, it turns into a line. And we'll talk in a moment what happens exactly at x equals 1. So if I'm trying to evaluate my function, at f of -4 using my graph. So remember, -4 is my input, it's my x value. So I'm going to go to -4 on my x-axis. So here's x, here's y. When I go to -4 on my x-axis, well, at that point, I haven't gone anywhere on my y-axis. My y value is 0. So f of -4 is going to equal 0. Go ahead and do the same for f of 2. Okay, and lastly, looking at f of 1, so this is that weirdo situation, I want you to predict what you think f of 1 will be. So looking at this, we've got two kind of different options. At 1, my value could either be -1, or it could be +1. However, I did call this a piecewise function, which means that it needs to be a function. So I can't have two different outputs at 1. I can only pick one of these values. So if you picked both of them, if you said, it's going to be -1 and +1, know that for this one, it actually has to only be 1. So I've got to choose between my closed circle and my open circle. Between those two, if you remember from graphing inequalities, if I'm graphing an inequality on a number line, let's say x is greater than 3. If it's greater than 3, then at 3 I'm going to put that open circle, meaning that x cannot equal 3. So my graph would look something like this. Versus if it's greater than or equal to 3, my inequality graph would have a closed circle at 3 and then go greater than. So a closed circle, like this one down here, means that it is a solution. So this is a solution. At 1 here, this is not a solution. It's just a starting point for that second part of my graph. So in this case, f of 1 is going to be -1. Okay. So from here, we're just going to briefly talk about real-world examples of functions, and this is kind of going to be our last topic for this lesson. So our first scenario is a person's location as a function of their time. Person's location as a function of their time. When we're considering real-world scenarios, our first step is going to be to identify the inputs and the outputs of our function. So you may remember from Algebra 2, maybe Algebra 1, talking about inputs and independent variables and outputs and dependent variables. Maybe the last time you did word problems in your math class. So when we're talking about inputs and independent variables, and I'll actually put this on notes so that you can see a little bit more. Okay, there we go. So if I'm talking about inputs, these are called my independent variables. And these are things that typically you can't really change. It will continue on its own, and it is not changed by the other variable. Not changed by the other variable. Versus my outputs are my dependent variables. The outputs are my dependent variables. And in this case, they are changed by the other variables. So they're dependent on the other variables or the input. So remember, my inputs are always my x values, outputs are always y values. So given this first scenario, a person's location as a function of their time, I want you to predict what you think is the input, my unchanging variable, and what you think is the output. I want you to give a short explanation for which is which and why. Okay, if you determined that the input is time and the output is location, you are correct. So in this case, time isn't going to change based on where I am. Time is going to keep moving no matter what. But my location might change based on what time of day it is. So I've got this function. If my function is where I am, or my output is where I am, I'm going to put L of t, where L stands for my location and t stands for time. So remember, L of t, or f of x, that's my output. And my input is time. So where I am is a function of time. So the next question is this a function? A person's location as a function of their time? Why or why not? Think about your given day. At a certain point or at a certain time, do you ever have two locations? Why or why not? Explain. So in this case, this is a function. If I consider different times, maybe at 8 o'clock, I'm in my classroom. And then at 12 o'clock for lunch, I decide to go outside. And then at 1 o'clock, I'm back in my classroom. But I can't be both in my classroom and outside on the quad or on the basketball courts at the same exact time. I can't be in two locations at once. So in this case, this is a function. Let's look at the second scenario. So in this case, I'm looking at the height of any student determined by their age. I want you to ask yourself, what is the input of this function? What is the output? So what is my independent variable? What is my dependent variable? Take some time to consider. I'll scooch this up. Nope. My age is going to be my input. My height is going to be my output. So my height somewhat depends on my age. If you think about a 2-year-old isn't going to be 5 feet tall, because that would be a little bit ridiculous. So my height depends on my age. So in this case, is this a function? Think about the people in your pre-calculus class. Do any of the students have the same input but different outputs? Okay, in this case, this is not a function. This will get more common as you get older, so maybe it's not this super common for babies. But if I've got a 17-year-old, so if I'm inputting 17 as my age into a height function, and my output, let's say I'm 17 years old and I'm 5'5". But you could also have a really tall 17-year-old, height of a 17-year-old who's 6'3". So in this case, I've got two of the same inputs and different outputs. I could also have a really short 17-year-old, height of 17, and I get an output of 5'1". These are all different potentials with different ages. And so my age doesn't necessarily depend, or my height doesn't necessarily depend on my age. That doesn't really make sense. This is not a function. Okay, and with that, that is the end of your first lesson. Double check your notes and see if there are any questions you still don't understand. Take a moment and star those so that you're prepared next week for a short exit ticket quiz in the middle of class. And if you need to go over any topics, we'll have time to do that together at the beginning.